Next, host negotiation protocol. From this title itself, you will get the clear knowledge on what is host negotiation protocol. Host negotiation protocol. We know that you just assume the same example, two mobiles. We are going to do a transaction between two mobiles. So we know that OTG protocols giving extra feature to each and every device only product. That feature is it will going to act as a host also. Okay. Now initially depending on that cable connection, one device will going to act as a master and another device will going to act as slave, right? But we have connected the cable, but these two mobiles wants to change their roles. For that some protocol is needed, right? They have to negotiate between them. At last one device will act as a host.
Even though the connection may be as it was already, I mean, since we are attaching mini A plug to one mobile,
Right.
okay, during that time that will act as a host.
Right.
Okay, but in between, since the second mobile want to act as a host, so we can make that host without changing those connection.
Yeah, that is the intent of this host negotiation protocol. Without changing the cable, they will going to change their roles. So under this topic, the subtopics we are going to discuss are HNP introduction and overview, HNP sequence of events, then OTG descriptor. We know that in USB we have so many descriptors and request, right? Descriptor in the sense that device will going to tell about their features to host, right? Similarly, one descriptor is there in a USB device that will tell the host that it's having the OTG extra feature. That descriptor we are going to see here, and then HNP timing diagram. Then we have discussed about under the OTG protocol we have two types of devices, A device and B device. So A device state diagram, B device state diagram we are going to see at last. Then one more topic, that is before the last topic, B peripheral only state diagram. OTG device which will going to act as a peripheral only. We are going to discuss about that thing also. Okay, at last we are going to see in under this HNP protocol. First we'll start with HNP. What is HNP? HNP, as we discussed at the initial time, depending upon the cable connection, anyway one mobile will going to act as a master and another mobile will going to act as a slave. But if without the changing of these cables, we want to change the role of those mobiles, means this HNP protocol is needed. The on-the-go B device, which is a default peripheral, may make a request to be host by utilizing the host negotiation protocol. This protocol eliminates the need for consumer to swap the cable connection in order to change the roles of connected devices. We have discussed these things, right? This is what HNP. And first we are going to see about HNP introduction during full speed. We have to consider the under the two speeds. First one is full speed. If the device is working in full speed, during that time how HNP is happening. If the device is working in high speed, during that time how HNP is working. We are going to consider both the things here. Okay.
I mean, full speed and low speed are under one category only.
Yeah. Okay. So host negotiation protocol, full speed. Here HNP means A device transition from host to peripheral. After the HNP, host negotiation protocol, A device transition from host to peripheral, and the B device transitions from peripheral to host. HNP is used to transfer the control of connection from the default host, what is that, A device, to the default peripheral, that is what, B device. This is accomplished by having the A device condition the B device to be able to take control of the bus, and having the A device present an opportunity, for the B device to take the control. You just think about that scenario. Now a device is transmitting some data. Okay, it has done its job. Now it is giving an opportunity to the B device to take control of the bus, so that it will going to act as a master, right? So that is what they are trying to say here. This is a sequence how HNP is happening here. First, what will happen? B HNP enable set by A device. At the initial setup, for example, first it will going to start with the reset operation, then enumeration, then data transaction. These are all the normal steps in USB, right? Here also the same thing will happen. During that enumeration time, anyway A device will going to receive descriptors. So after that, the A device has to condition the B device. Condition here means it will going to set that BHNP enable. If the B device is telling the A device that it's having HNP capable, then it has to set that particular bit, so that the host negotiation protocol will happen. So first step is set by that bit is set by A device. Second, how the A device is giving opportunity to the B device. A device suspend the bus to signal B device that it may take control over the bus. And third, if the B device want to use, then it signals a disconnect to the A device. Second step, suspension. A device suspend the bus. Third step, B device is requesting by disconnect the bus.
What did disconnect mean? How will it disconnect the signal?
Yeah, generally in USB we have single-ended 0, single-ended 1, JK states are there, totally 4 states, right? So one signal, for example, disconnect means single-ended 0. Okay, and this disconnect will be recognized as a request by A device. Okay, and then A device will complete the handoff by turning on its D plus. We know that D plus and D minus are two main lines in USB. How the A device is acknowledging? You just look at that. A device is acknowledged by turning on the D plus line. So now the B device will hand over the bus by stopping the bus and turning on D plus. Now the B device also turning on its D plus when in the full speed idle. Now A device will detect the lack of bus activity and turn off D plus. When A connect as a signal from the B device, it will resume its operation as a host. Okay. So this is the sequence of HNP process. Now we are going to see this same sequence in a diagrammatic view. You just see here, this is one mobile side, this side is one mobile side, and this side is another mobile side. Okay, now this mobile by default acting as a host, and this by default acting as a B peripheral. Okay, now assume that this host has completed its work. That means it has transferred data, and now it's free. During that time it will go to suspend state. Okay, so we have before only we have seen that suspend means it is the opportunity for the B device to behave as a host, right? So after the deduction of this suspension, A bus suspend, B device will